Hi everyone. In this video, you will learn how to draw functions with the given limit properties. Let us start with an exercise right away. Draw a graph of a function that satisfies two limit conditions. The limit of this function as x approaches -2 must be -3, and the limit of this function as x approaches 3 cannot exist. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. First, I find x equal to -2 on the x-axis. Now I know that as the inputs approach -2, the outputs must approach -3. As the inputs approach -2, the outputs must approach -3. This is how I'm going to achieve this. I'm drawing a piece of the graph. That piece satisfies the given limit condition. As x's approach -2 from the left, the values of the function get closer and closer to the value of -3. As the inputs of the function approach -2 from the right, the outputs of the function get closer and closer to the value of -3. Let's take a look at the second condition. The limit of this function as x approaches 3 cannot exist. I find x equal to 3 on the x-axis. To make sure that the limit does not exist there, I will make sure that as the inputs approach 3 from the left, I get some value, and as the inputs approach 3 from the right, I get a different value. For example, as x's approach 3 from the left, I will make sure that the values of my function get closer and closer to 2. As the inputs of my function get closer and closer to 3 from the right, I will make sure that the values of my function get closer and closer to -1. Now, the limit at x equal to 3 does not exist. I want to point out that I couldn't have this dot closed filled in and this dot closed filled in as well. I needed one of those dots to be open, to be not filled in. If both of these dots were closed, then the input of 3 would be associated with two outputs, the output of 2 and the output of -1. This would mean that this wouldn't be a function anymore. Remember, a function has for each input at most one output. For the input of 3, you can have only one output. You couldn't have the output of 2 and the output of -1. If you did, that wouldn't be a function anymore. What you could have also is to have this dot open and this dot closed. What you also could have would be to have this dot open and this dot also open. That would mean that the function is simply not defined at x equal to 3. Now, this graph is not the nicest graph you could have. It consists of 3 pieces. What's more, you don't know the value of this function at x equal to -4, for example. You also don't know the value of this function at x equal to 0 or at x equal to 1/2. To make sure that this function is defined for as many x's as possible, I will extend the bottom piece all the way to the left. This will still be a function, and this will not invalidate any of the conditions given in the problem. I will also connect the piece on the left with the piece on the right to make sure that the function is defined for as many values as possible. Note that I could not connect the bottom piece with the second bottom piece. If I did so, then the input of 2 would have the 2 outputs associated to it, which means this would not be a function anymore. So the only way I can connect these pieces is to connect the first piece with the second piece. I cannot connect it with the third piece. I have one more problem for us to try. If you would like to try this problem on your own first, this would be a good time to stop the video. I will go through the conditions one by one. First, the value of the function at -4 must be 2. I find -4 on the x-axis, and I know that the value of the function must be 2 there, so I add a green dot with coordinates -4 and 2. Then, the limit of this function as x approaches -4 must be 2. So, as I approach -4 from the left and from the right, the values of the function must be getting closer and closer to 2. The easiest way to do this is to draw a piece of the graph that goes through that point. Let's continue. The value of the function at -2 must be 4. I find -2. I know that the value of the function must be 4, so I add a solid dot with coordinates -2 and 4. Next, the limit of the function as x approaches -2 must be 3. I find x equal to -2 on the x-axis. I approach it from the left and from the right, and I must be getting closer and closer with the values to 3. The easiest way to achieve that is to have a function that goes through that point being an open dot. That point must be open, because if it was closed, then the input of -2 would be associated with 2 outputs. And again, one input can be associated with at most 1 output. So you cannot have both of those dots closed. Next, the value of the function at x equal to 1 must be -2. I find x equal to 1, the value of the function must be -2. Next, the limit of this function as x approaches 1 cannot exist. So as I'm approaching 1 from the left or from the right, the limit cannot exist. I will achieve that by having the different left limit from the right limit. For example, from the left, I will be getting closer and closer to 2. From the right, I will be getting closer and closer to -2. Finally, the limit of this function as x approaches 4 must be 0. So, as I get to 4 from the left and from the right, the values of my function must be getting closer and closer to the point with the y-coordinate of 0, the point on the x-axis. So what I'm going to do is I will simply draw a graph. I will continue this graph and I will make sure that it goes through the point x equal to 4, y equals to 0. Note now that as x's approach 4 from the left and from the right, the y values of this function approach the y value of 0.